All right, here we go, the backside of the 2-6 notes. And we are solving using the rational root theorem. So I'm just getting a little more practice on this here. Taking our, and it's already in descending order for us, we don't have to do any work there, but we're going to take all the factors of our of our constant. And so we've got plus and minus 1 and plus and minus 2 divided by all the factors of our leading coefficient. So again, plus or minus 1 and plus or minus 2. So we've got 1 over 1, which is 1, and 1 over negative 1, so negative 1, and 1 over 2, and 1 over negative 2. Let's just go ahead and rewrite these kind of in a little more friendly, space-friendly form here. So our possible rational roots are going to be plus or minus 1, that's 1 divided by 1, plus or minus 1/2, that's that one there, plus or minus 2, that would be 2 divided by 1, and then plus or minus 2 divided by 2 would be 1 again, but we've already got that there, so that's a repeat. We don't need to write those ones down again. So here's our 6 possible rational roots. And we're just going to go ahead and use the synthetic division to see if they are in fact roots. So 2, negative 1. Let's give ourselves a little more space. 2, negative 1, negative 7, 1, and 2. And let's start with 1. So 2, 2, 1, 1, negative 6, negative 6, negative 5, and we can see now that's not going to work. Negative 5 and negative 3. So negative 1, or sorry, 1 is not a factor. Let's try negative 1. Oh, erase for me. There you go. Let's try negative 1. So 2, negative 2, it's negative 3, 3, negative 4, 4, 5, and yep, this one's not going to work either. Negative 3. All right, continue. So 1 didn't work, negative 1, and those are done. Those are not going to be our roots. And so let's try 2. 2 is a little bit, looks like a good one to try here. So 2, bring down the 2, gives us 4. That's 3, 6, negative 1, negative 2, negative 1, negative 2, and there we go. That one is a root. So we have, if 2 is a root, then our factor is going to be x minus 2 times 2x to the third plus 3x squared minus x minus 1 equals 0. And we're going to have to keep on breaking that down. So get some more space here, clean these out. So our coefficients now are 2, 3, negative 1, and negative 1. And 2, we just used 2, but 2 could also, it could be a double root. So we got to try it again. Bring down the 2. Gives us 4, 7, 14, 13, 26. Not gonna work out. That's 25. That's not. So 2 we're done with. We've tried. Oh, actually, we haven't tried negative 2 yet. Negative 2. All right, gives us 2, negative 4, negative 1, 2, 1, and nope, that's not going to work either. So we got negative 2, which adds up to negative 3. So 2 is done now, and we'll keep on going. We're still trying to find some rational roots here. We'll try 1/2. 1/2, so 2 times 1/2 is 1, adds up to give us 4. Half of that is 2, adds up to 1. Half of that is 1/2. And that gives us negative 1/2. And so, nope, that's negative 1/2, or positive 1/2 didn't work. Let's try negative 1/2. negative 1/2. And 2 times negative 1/2 is negative 1, gives us 2. That's negative 1. Negative 2 is positive 1, and that one does work. All right. So keep on going down. So we already had x minus 2. Now we have pulled out x plus 1/2. And we're left with 2, oh, that's pretty ugly, 2x squared plus 2x minus 2 equals 0. All right, and that one there, now we can use our quadratic equation. It could be that it's going to be negative 1/2 because we already have eliminated all the other options. Negative 1/2 could be another repeating root, but don't believe that it is. And let's go ahead and just do our quadratic formula. So A is 2, B is 2, and C is negative 2. And as you go on through, you'll solve that, and you'll get that x is equal to 2, that was our first root, negative 1/2, that's our second root. And using the quadratic formula, I'm hoping you come up with the 2 roots of negative 1/2 plus square root of 5 over 2 and negative 1/2 minus the square root of 5 over 2. So there's our roots. 1, 2, 3, and 4. All right. Hope that helped.